Hello, I'm Hans Guesgen from Massey University in Palmerston North. Today I would like to talk about using rough sets to improve activity recognition in smart homes. Smart homes have been a hot topic for quite a while, and especially activity recognition in smart homes. There has been a significant amount of work, and much of it is based on sensor data. When using sensor data, spatial information is often treated implicitly. What we want to do here in this presentation, we want to view spatial information as context information. That means we want to use spatial information to boost the activity recognition process. Here's an example of a CASAS dataset, which we used in the evaluation of our approach. What you can see here is a floor plan of an apartment, and the little black dots on this floor plan signal sensors, in particular motion sensors. When we look at motion sensors, we can observe that they correspond to some physical space in the smart home. But this space is not precisely defined. A tall person, for instance, might trigger a motion sensor much earlier than a smaller person. So depending on the person, the space that is actually corresponding to a set of sensors differs. What we are going to do is we look at what we call activity spaces. So given a particular type of activity, which means a set of instances of that activity, we look at what space corresponds to this activity. Given a particular instance, we have a precisely defined set of sensors that corresponds to this instance, but looking over all instances of a type of activity, we might observe differences in these sets. So we need something to express vagueness in the space of activity. The approach we are taking here is to use rough sets to express that vagueness. A rough set consists of two crisp sets, regular sets. One is called the lower approximation, and the other one is called the upper approximation. Let's assume we observe a set of activities of a particular type of activity. Then each of these activities corresponds to a particular set of sensors, S1 through Sm. When we intersect all these sets, we get the set of sensors that occurs in all of the instances, and we call it the lower approximation of the activity space. And if we compute the union, we get the upper approximation of the activity space. So the rough set consisting of the lower approximation and the upper approximation is called the activity space, and it gives us some indication of what space a particular type of activity corresponds to. What are we interested in is the difference between the lower and the upper approximation, because that gives us some idea how precisely defined an activity space is. Of course, if the boundary space is empty, then we know that all instances of a particular type of activity correspond to exactly one space. That means that the activity space of A is precisely defined. And if this is not the case, we have some vagueness in there. Just looking at the size of the boundary space is not a fair comparison. So what we need to do is we have to normalize somehow the boundary space. And what we do is we look at a concept called accuracy of the activity space. And the accuracy of the activity space is the size of the lower approximation of A over the size of the upper approximation of A. If the accuracy is 1, that means that the lower and the upper approximation have the same size, and therefore we know the activity space is precisely defined. Now the next question is, how do we actually use this concept? We want to use this concept to boost activity. So let us assume after evaluating some data sets, we obtain a set of type of activities, A1 through AN. And for the sake of simplicity, we assume that each of these type of activities corresponds exactly to one activity space, one rough set. And let us now assume that we observe an instance of a new activity. Let's call this instance B. And of course, it's because it's just one instance, the lower approximation and upper approximation are identical. What can happen is that B is not a superset of any known lower approximation of an activity space. This most likely means that we have not seen this type of activity before. It might be a novel activity, some abnormal activity. We really don't know. We cannot make an assumption and therefore cannot really use that information in our activity recognition process. A more fortunate situation would be case 2, where B is exactly one lower approximation, a superset of exactly one lower approximation. And this means that we have seen before the set of necessarily involved sensors. So we can then conclude that B and AK are related to each other, that they belong to the same type of activity. But it could also be that there's more than one known lower approximation of an activity. So in this case, we can have a look at the upper approximation and look how close the upper approximation is to our known activity B. The closer it is, the more likely it is that we have hit the activity that we are looking for. To conclude my talk, obviously the accuracy depends on the size of the boundary space, and that's something we have to look carefully at. What I have also not mentioned is that some of the activities can actually occur in more than one space. Think of sleeping, for instance. A person might sleep in bed at night, but might have a nap on the couch in the lounge during the day. In this case, it doesn't make sense to actually talk about one activity space, but it would make more sense to talk two activity spaces. And we are using hierarchical clustering to actually find out about these spaces. We have also only done limited evaluations on smart home layouts, and obviously they play an important role. If we are looking at a one-room apartment where all of the activities take place in the same room, spatial information is not really indicative of which activity takes place. If you have a multi-room home with dedicated bedrooms, lounge, kitchen, dining room, and so on, it's much easier to use this information and to inform the activity recognition process. Thank you very much for listening.